BookmarksEducare welcome you all to our live session. Today we are coming with a chemistry live session once again. So, what is today's topic? Starting with a funny note. It's a short poem. Ores be like, don't heat me bro, metallurgists too late, into the furnace you go. From dullness to shineness, from mess to glory, metallurgy, it's the end of the story. So today's topic is metallurgy in one shot. So what is metallurgy? Metals, non-metals, metalloids, ores, minerals, everything comes under the topic metallurgy. So today's live session will be all about metallurgy. So this metallurgy can be divided into 4 chapters. One is, as you have in all topics, a short introduction. So there will be a short introduction regarding what are metals, what are non-metals, what are metalloids, their occurrence, their properties, etc. Then comes the metallurgy, that is the process of extraction of metals from minerals, from ores, etc. Next is considering aluminium. How can you extract aluminium from a particular ore? So that will be taken care of. And the third one is about alloys. Today in this live, remember, we'll just take some crisp shots because this is a live session. If you want to know more in details, you have to come to us. In our website, the courses are there. We will be giving you mentorship on each and every topic. Mentorship means we will be providing 1:5. There will be dedicated one faculty member for only 5 students. Remember, only 5 students, not more than that. So you come to us with your queries, with your doubts on each and every subject we have, not only chemistry, we give you physics, maths, biology, everything. So please come up to us, follow us in our website, stay connected with us in our meta pages in Facebook, Instagram. Come to us, follow our live sessions, get regular updates in our YouTube page. So not without any delay, we just jump into the topic. So coming to the introduction, you know, Mother Earth, it has very rich sources of minerals, sources of metals. Till date, there are 118 elements that are present, of which, and they are present in the Earth's crust, either in the free form or in the combined form. Out of these 118 elements, they are classified as metals, non-metals, metalloids, etc. So, with this 118 elements, only 17 elements are there which are non-metals in nature. So, what are basically metals? Now, with the term metals, what comes into our mind? It has got high melting point, high boiling point, high density, high tensile strength, it is tough. It is good conductors of heat and electricity. Metals are basically formed when they lose electrons. That means metals generally forms cations. Once a metal loses electrons, it will generate cations. But there is one exception. The exception is hydrogen. Hydrogen, although it is a non-metal, it still gives up electrons to produce a proton. So hydrogen, when it is giving up electron, what it generates? H plus ion, which is nothing but a proton. So you see, and this metals, the advent of metals and non-metals dates back to many centuries, because earlier mankind used metals to generate utensils, weapons, etc. It was, metals can be drawn into wires, they can be beaten into sheets. So copper was the first metal that was used by mankind to prepare utensils and weapons. And non-metals, so as I said, metals are copper, sodium, potassium. What are non-metals? Non-metals are generally formed when they are gaining electrons. That means non-metals usually form anions. Okay, so metals lose electrons to generate cations and non-metals gain electrons to generate anions. So non-metals are those which form negative ions when they lose electrons. But hydrogen, as I said, it is a non-metal although it is losing electron. Now, what are metalloids? Metalloids are elements that have properties of both metals and non-metals. So, examples of some metalloids are boron, germanium, polonium. So, these are examples of metalloids. Now, coming to the periodic table, if you see, metals occupy the left side of the periodic table and non-metals occupy the right side of the periodic table. And metals and non-metals are usually separated by a zigzag line, which is, this is the zigzag line which separates the metals from the non-metals, and it is the metalloids. Okay, so the metalloid separates metals and non-metals. Okay, so the metalloids are boron, silicon, germanium, arsenic, antimony, tellurium, polonium, etc. Okay. Now, where do you find these metals? As I have earlier mentioned that the Earth's crust or our Mother Earth is very much rich. These metals and non-metals are all found in the Earth's crust, okay? Either in the free form or in the combined form. When will it be in the free form and when in the combined form? These metals have a tendency, combined means they will have a tendency to combine with something. Combine with what? Oxygen, hydrogen, water, carbon dioxide, etc. So whenever metals are reacting with other, that means they are reactive in nature. Those reactive metals will have a tendency to combine. So what will happen? If they have a tendency to combine, they are reacting, that means they are present in the combined state. But those metals which will not be able or which will not have the tendency of combining, they will be present in their native or free state. Okay. So here you see a reactivity series. Now according to the order of reaction or reactivity, metals are aligned in a particular series. Now in this series, what do you see? That potassium, sodium, calcium, barium, they occupy the top position of the series, okay? And this hydrogen, okay, this is in the middle, which is a separation between lead and copper. So hydrogen lies in between lead and copper, and towards the down you have copper, mercury, silver, gold, platinum. Okay. So the less reactive metal lies at the bottom of the series. Okay. That means gold, silver, platinum, they can be present in their native or free state. But in the combined state you have potassium, sodium, potassium oxide, sodium oxide, they are always found in their combined state, either in the form of oxides or in the form of carbonates or sulfides. So they are always found in their combined state. So as I have said, see that sodium, potassium, they occur mostly in the form of chlorides, calcium, magnesium in the form of carbonates, aluminium oxides, zinc and lead, copper, they usually found as sulfides. Now is coming to minerals and ores. What are minerals and what are ores? Minerals are basically these metals, the naturally occurring metals that are fixed or that are mixed with substances like rock, sand, mud, clay, etc. Right? So these earthly impurities, okay, what are they known as? They are known as gangue or matrix. So what are minerals? Minerals are metals that are combined with earthly impurities like mud, clay, sand, stone, etc. What are ores? These ores are minerals from which the metal or pure metal can be extracted at a low cost and with less effort. Okay. So ores are basically minerals from which the crude metal can be extracted at a very low cost and with less effort. Now there is a basic tagline which you follow. Not all minerals are ores, but all ores are minerals. That means if I take a ore, it is necessarily a mineral, but a mineral always is not an ore. Is it clear? So if I ask you names of some ores, like aluminium metal is extracted from its ore, bauxite. Okay, bauxite is a common ore of aluminium. What it is known as? It is hydrated aluminium oxide, Al2O3.2H2O. Okay, so this is hydrated alumina is known as bauxite. Similarly, iron is extracted from the ore hematite, Fe2O3. Next is zinc. Zinc can be extracted from its sulfide ore, which is known as zinc blende. Okay. Now is metallurgy, the extraction of metals. But I will not take this session here. If you want to know the total process of metallurgy, what is metallurgy? It is the process of extraction of the metal from its ores and the production of alloys. But I will just leave it here because for this to know details about metallurgy, what are the steps, what are the extraction processes, how aluminium can be extracted from its ore bauxite, you have to come up to us with your queries, with your doubts regarding this part in our mentorship sessions, which information you can get in our website bookmarkseducare.com. So please visit our website, know about our courses, come to us and learn more in details about metallurgy. But will I leave the session here? No. I will take again a crisp part of the metallurgy portion, that is about alloys. So moving forward to what are alloys, right? Now what do you think what are alloys? Do you have any idea what are alloys? Alloys, now if I tell you, like, again I am giving you a very funny representation. Metals, when they are alone, they are me. Alloys, when combined, they are ye. So boom, you are getting a new personality. So alloys are basically combination of metals. When metal combines, or when metal combines with non-metallic elements, they generate alloys, right? So alloys is a homogeneous mixture of two or more elements or more metals with non-metallic elements. Now, these alloys, why do we develop alloys? Whenever we want to improve the functionality of the particular component in the metals, like copper has certain strength, but whenever you are making copper, mixing it with zinc, you form an alloy brass, right? So copper tells zinc, come let's blend, and you generate brass. Brass is very much lustrous, it gives much shine than its individual components, copper and zinc. Brass, you use brass to prepare ornaments. So you can see how much lustrous it becomes when copper is combined with zinc. So in order to augment the individual properties of the component metals, alloying is done. Okay. So what are fusible alloys? Alloys that melt in the range of 51 to 260 degrees centigrade and usually contain lead, tin, bismuth are known as fusible alloys. That means they can be present or in their molten state easily. What is alloy steel? The steel which contains approximately 10% of elements like chromium, molybdenum, nickel and a low percentage of carbon gives you alloy steel. What is an amalgam? An amalgam is a mixture or an alloy of mercury with several other metals like sodium, zinc, gold as well as some non-metals. So whenever you say amalgam, that means mercury will be present there. Anything but mercury is constant and any other metal you can have for amalgam. What is dental amalgam? It is an alloy of mercury and silver tin alloy. Mercury is a amalgam I said, but mercury does not form amalgam only with iron, right? So mercury is usually often stored in iron bottles. So if a question comes that justify why mercury is usually stored in iron containers, it is because mercury do not form any amalgam with iron. Okay. Next is that I was telling that what is the purpose of alloying, right? Now, alloy, the main purpose is to improve the specific usefulness of the primary component but not to adulterate or degrade it, okay? So, you are augmenting the properties of the metal components but you are not adulterating or degrading it. Like, if you can increase the strength of iron by making it or converting it into steel. Similarly, brass is stronger than its components zinc and copper. Also, aluminium bronze is an alloy but it looks similarly like gold because of its bright yellow color. Nichrome is an alloy which is made up of nickel, iron and chromium which is very much resistant to electricity. Next is carbaloy. It is an alloy of tungsten, copper and cobalt. Okay? And it is as hard as diamond. Bell metal, it is an alloy of copper and tin, but it is more sonorous than copper and tin. Next is alnico. It is an alloy of aluminium, nickel and cobalt. And it is so heavy that it can lift up 60 times its own mass. Solder, it is an alloy of lead and tin. Tin is basically added because it lowers the melting point to 180 degrees centigrade of the alloy that helps in soldering purposes and helpful in electrical connections. Similarly, type metal is an alloy of lead, tin and antimony. This antimony and tin helps in the addition of casting properties, so it can be easily cast and used in printing blockages. Similarly, sodium amalgam is much less reactive than sodium and it is a liquid alloy at room temperature. Okay. So, give an example of a liquid alloy at room temperature. The answer will be sodium amalgam. So, basically you see that upon allowing, what is happening? The specific usefulness of the particular components of the elements are being augmented. Rather, they are not adulterated or the properties are not degrading. Next is the reasons for alloying. That is, one is to modify the appearance and color. See, in aluminium bronze, which is an alloy of aluminium and copper, it is resembling gold because it is bright yellow. Next function is to modify the chemical stability. Sodium amalgam is an alloy of sodium and mercury, so that is less reactive than sodium. Next is to modify the casting ability. As I said, type metal is an alloy of lead, antimony and tin which expands on solidification and can be easily casted. Next is to lower the melting point in case of solder, which is lead and tin. Tin is added to lower the melting point to 180 degrees centigrade. Therefore, it can be easily used for soldering purposes. To increase hardness and tensile strength, brass, it is hard than copper. Duralumin, which is an alloy of aluminium. Copper is added, it gives hardness and toughness. To increase the resistance to electricity, nichrome is an alloy of nickel, iron and chromium and it is very much resistant to electricity than copper. Next is how are alloys prepared? They are either prepared by fusing the elements, that means by fusion of two elements or mixing the two elements, you can prepare the alloys. Example is brass. Brass can be prepared by melting zinc and copper. Similarly, another method is by compressing the finely divided metals. Here wood metal, which is a alloy of lead, tin, bismuth, cadmium, is a fusible alloy, right? And it is used in where sprinklers, it is sprayed with water in order to stop the fire. So you see here, I have given different pictures where alloys are used in our daily life. Here you see a brass ornament. This is very common. You see all girls, women, they have in their hand. This is a brass ornament. A stainless steel coffee mug. Stainless steel is a very good alloy. A bronze statue. Okay. And this is, I was talking, solder wire. The wiring or the solder alloy, that is the alloy of lead and tin, that is used to produce wires like this. Now, alloys are solid solutions. How? Question comes, solutions, then how come it is solid? Solutions कैसे होता है? Solute solvent में dissolve है, solvent तो liquid होता है, लेकिन solid solutions कैसे होता है भाई? तो कैसे होता है solid solutions? Alloy are solid solutions because whenever you are mixing, I said by mixing the metals you are generating alloy. Suppose in brass, I have copper and zinc. So, the metal component which is in higher concentration, that acts as the solvent in the alloy, and the metal component which is in lower concentration, that acts as the solute. So, brass is nothing but a solid solution of zinc and copper. Okay. So, copper is in excess in brass. That means copper is the solvent and zinc is the solute. Clear? So, alloys are nothing but what? They are solid solutions, right? So, very important questions can come. Justify alloys are solid solutions. Then with the example of any alloy, you have to explain which is acting as solute, which is acting as solvent, and ultimately alloy is nothing but a solid solution. Next is some typical examples of alloys, their properties and uses. First I take aluminium. In aluminium, the common alloy is duralumin, which has 95% aluminium, 4% copper, 0.5% magnesium and 0.5% manganese. Okay? It is light, hard, resistant to corrosion, highly ductile. The aluminium imparts lightness, whereas magnesium imparts strength. It is usually used in aircrafts, tube trains, to develop the body of the tube trains, aircrafts, buses, in light tools and also sometimes in pressure cookers. Next alloy is magnesium. Magnesium is 90 to 95% aluminium and 10 to 5% magnesium. It resists corrosion, light and strong. It is used in aircraft, scientific instruments, metal mirrors, etc. Next is iron. The most important iron alloy is stainless steel. You have all heard SS. SS is the short form of stainless steel. It contains 73% iron, 18% chromium, 8% nickel and 1% carbon. It resists corrosion. It is lustrous, hard, resistant to acids and alkalis. The nickel and chromium is added, which imparts a luster. Carbon is added, which imparts hardness. Used in utensils, cutlery, ornamental pieces and surgical instruments. Another is manganese steel. It contains iron, carbon, manganese. It is durable, hard and tough. It is usually used in safes, rock drills and armor plates. Next is tungsten steel. It contains iron, tungsten, carbon. It is very hard and it is used in cutting tools. Next is the metal lead. Lead, two important alloys. One is solder or fuse metal and the other is type metal. Solder, as I said, contains lead and tin. Low melting point, because tin lowers the melting point, it is used in electrical connections for soldering purposes. Next is type metal. Type metal contains lead, tin and antimony. Tin and antimony enhance the casting property, therefore it helps in expanding on solidification and therefore it can be used for casting purpose. Next is zinc and copper alloy. Important is brass, it is copper and zinc. Okay? Brass ornament, or you see here a picture of brass where you have a utensil like brass. So it is malleable, ductile, it can be easily cast, it resists corrosion, it is yellow or silvery in color. Decorative hardware, it can be used in utensils, parts of watches, musical instruments, etc. Next is bronze. Bronze medals, you see bronze medals are very common. It is an alloy of copper, tin and zinc. It is hard and easily cast. It can be polished. It resists corrosion. It is used in metal, statues, bearings, coins, etc. The next is German silver. It is an alloy of copper, zinc and nickel. It is white and light like silver. It is malleable, ductile, high electrical resistance and it is generally used in resistors, rheostats, etc. So here you see brass, bronze. This is duralumin, that is you can be used in the body of the aircrafts. Stainless steel used in surgical instruments, and this is solder, an alloy of lead and tin that is used for soldering purposes. So these are the different typical or very common alloys that you encounter in your daily life to increase or enhance the properties of the single metals. So this is all for today's live session. If you want to know the main part, that is the metallurgy, the process of extraction of the metals, come to us for our mentorship program. Again, I am telling, mentorship program doesn't mean 1:2 infinite number of students. It is just one educator and 5 students. One educator dedicatedly for 5 students, where one-to-one interaction is possible. So come up with your doubts, with your queries. Get prepared yourself for your upcoming board exams. We are there to help you. Stay updated with us. Follow our meta pages, YouTube, Instagram, Facebook. We come with a whole lot of live sessions, not only chemistry, physics, biology, maths, everything. Daily we come up with some very good sessions, one shots. So please come up to us at bookmarkseducare.com. Thank you. Ma'am, what metallurgy and কোশ্চেনটা কোথায়? এটা উপাধ্যায়জি আর এটা প্রিয়াঙ্কা শর্মা। Okay, in YouTube live chat, I see there are two people. One is Upadhyayji and one is Priyanka Sharma. If you have any doubt regarding metallurgy, you can please type your questions in the chat box. We are still here. The session is going on. We can then revert back to you. If you have any doubt, I am again telling, please type there. Or if you want to know more about our details about BookmarksEducare, come to us at our, this is our contact number. Please, you can take a screenshot, save it. Our contact details are there. If you want to know queries later on also, you can contact us directly. We will entertain your query. This is our website, bookmarkseducare.com. We have our Facebook, YouTube and Instagram pages. Come to us, and again I am repeating again, now if you have any doubt, you can type your questions in the YouTube chat box. You take a screenshot of this. This will be important to you for your further discussions. You can contact us directly. We give you updates. We will let you aware about our program much more in details.